Hey guys, my name is Frank, and this is the Poth on Programming video log, and today I am bringing to you a tiny snake example that I wrote in JavaScript to highlight the different techniques that I showed you guys recently in my latest set of tutorials on tile-based game development. So basically, Snake is a super simple tile-based game, and the way the snake moves is you take the tail end of the snake out of the array of indices in the snake's array of his segments, and you move it to one step ahead of the head segment in the snake. And how you draw the snake is everything is entered into the tile map. So what you see on the screen, the apple, the snake, the gray background tiles, those are all just parts of the main tile map. And you just loop over them and draw them just like you would draw your regular tile map. Basically, everything you see is just a tile in the map. So I've implemented a few classic features of Snake, like you get faster as you move. There's an apple that respawns in a random location. So it's basically what you would expect. It's a Snake game. So now I'm going to get into the code. I'm not going to go over the controller or really the display too much because you've seen it before. The controller is really simple. I mean, this is it right here. Look at it. Simplicity at its finest. I'm going to come down here to the display and go over a couple things in display. So output is just my output P element that has the score there. And the interesting thing here that I want to show you guys is how I did the graphics. So I didn't feel like drawing my own set of tiles in GIMP or anything like that. So what I did was I just used the built-in drawing API to draw my graphics. So if I come over here, you can see that I have an object called graphics, and inside of it are other objects labeled with numbers that correspond to their tile values. So like 0 in the map, this would be a 0. In the map, this would be a 1. And in the map, this would be a 2. The apple is a 2. So these labels here, 0 corresponds to a background tile. So there's a canvas stored in this object that holds the background tile image. And when I start up the application, so when I start up my browser and visit the page, the snake page, this draw function is called, and it will draw all of these drawing commands to the canvas's context. And then later when I want to draw it, I just come down into my render function, if I can find that, which is right here. I get the graphic out of the graphics object with the value that I'm currently over in the tile map, and I just get its canvas, and then I go ahead and draw that graphic or that canvas to the buffer at the specified location. Well, I guess it's not specified, but at the location that I determine with these formulas for converting 1D map coordinate space to 2D tile world coordinate space. And I've gone over that in other tutorials as well. So it's really simple. It's just a slightly different way of approaching it. If you don't feel like having your own graphics set, you can reduce your file size this way by drawing your graphics at startup. And if you have a simple game and it doesn't have a lot of complex graphics, it's really not a big deal. It's actually probably preferable to do it this way, as opposed to just having a tile set that you import of just square graphics, because that would be kind of lame. Excuse me. The other thing is, since these are objects labeled with, or the graphics are labeled with numbers, I wanted to keep track of them more easily, so I have these handy. They're not enumerated, but they're just values with the corresponding numbers for what the graphic is. So for instance, a background tile would be a 0 in the map, a segment is a 1, and an apple is a 2 in the map. So instead of remembering 0, 1, and 2, I remember background tile, segment, and apple. Much easier. Alright, and that's probably about it for the display. Now I'm getting into the game object where all the cool stuff is. So a couple different things happen if I come over here to the example. I'm going to have to be able to get an apple. The apple is going to have to respawn in a random location that is not on top of the snake, because why would you want to spawn the apple on top of the snake? So there's going to be a couple interesting conditions for that. The other thing is I can pause the game by pressing the opposite direction the snake is moving. So right there, I was moving to the left. I pressed the right arrow key and it stopped the snake's trail of movement, or stopped the snake from moving basically. So I've implemented that. The other thing is, if you collide with yourself, obviously you die in the classic snake game. Collide with the wall, top, the left, the right, the bottom wall, you're going to die. So all those things have to be covered inside the game loop. Before I can do that, I have to define a couple things like my score, my apple, and my snake. So the apple is really simple, and the snake, it's all really simple. It's the simplest tile-based game concept I could really come up with was snake. I didn't come up with it, obviously, but I did make this example of snake, and I just wanted a simple example to show you guys how to make a game with these tile-based concepts. So the apple simply just stores an index in the map. So this map is 400 spaces. So anywhere between 0 and 399, I can place this apple pretty safely. And to start, I don't really care if the apple ends up on the snake. I just didn't feel like putting that condition in there. I mean, what are the chances? And I guess it doesn't really matter on the first turn. Never had it happen. I do take care of resetting the apple's position, particularly when the snake is very long. It can be a problem if it respawns on the snake. So I do take care of that, and you can work that into the spawn position of the apple when you start the application. So then I come over to the snake, and as you can see, the snake is a very simple object. All it does is keep track of its head index, which is at position 209 in the map, so that would be right here. This is the snake's head, and it keeps track of its different segments, or where the segments are in the map. So the segment indices, which are 209 for the head and 210 for the tail. So this is position 209, this is 210. And it also keeps track of the vector of movement, or the direction. The other thing it keeps track of is the old head index, and to start, that's undefined. The reason for this, keeping track of the old head index, is so I can pause the game. So if on my next move, my snake is going to move here, the old head index will be stored here, and now I know if I press right, I'm going to try to move my head into the old head index space, and I'm going to pause the game. So if I want to pause the game, I can do that. And it's kind of like cheating. I guess you wouldn't really want that in a snake game, but I figured for the purposes of testing it out, I put the pause feature in there. I think it's kind of cool. So really simple snake and apple objects. The world, there's one cool line in here where I define the map without actually manually typing out 400 zeros or copying and pasting a bunch of lines of zeros. You can define an array and fill it with a certain value simply by setting the size of the array in the array constructor. So I set my array up to have 400 spaces, and then I called the fill method to fill all 400 of those spaces with 0. But I'm pretty sure an array defaults to 0 anyway, but don't hold me to that. I'm not sure if that's JavaScript or not. But you can use this method to fill your array with anything you want. So for instance, if I came over here and filled it with a 1, or better yet, I could say, what is it? Display dot apple. And I come over here and refresh. Now my background map is full of apples. And for some reason, the snake doesn't seem to be gathering that. Well, actually, the reason is because the snake only interacts with the apple object, not just tiles that are apple shaped. But how cool is that? I'm like plowing my way through a bunch of apple tiles. I'm not growing at all, but it's interesting to look at. So that's pretty cool. This is actually the first time I've actually tested that out. But anyway, we just want to fill our map with background tile. Bam. So there we go. Then we're getting a little bit closer to the game loop. So what we're going to do is we're going to define some stuff that we use in the game loop. So obviously the snake moves kind of slowly in increments of time. I don't want to redraw the map between when the snake is moving. Why would I want to redraw the map if nothing has changed? So I'm only going to want to redraw my map every 250 milliseconds to start. And then every time the snake hits the apple, I'm going to subtract 10 from that 250 until I think I get to about 100 milliseconds between frames. Then I also have to keep track of accumulated time to make sure that I'm following this time step in my loop appropriately. I'll get into that when I hit the game loop. First, I'm going to quickly go over this reset function. All this does is reset the game to its default value. So obviously, if I come over here, I get an apple, I hit a wall, the game resets. Simple. So all this function does is just reset everything to its default values. But keep in mind accumulated time and time step, because we're about to get to the game loop. And that is this. So the loop basically executes every time request animation frame. I guess request animation frame events fire, or every time the browser window is ready to be redrawn, this loop will fire. But we don't want to update our game logic that quickly, so we have to keep track of our time step, not our time stamp, that 250 milliseconds, and the accumulated time to make sure we only execute our game logic code whenever 250 milliseconds has passed since the last frame, if that makes sense. So it's almost like a fixed step loop, but not quite. It's kind of like a makeshift fixed step loop that you wouldn't really want to rely on to. Actually, it is a fixed step loop, but it doesn't drop frames, so to speak. It draws every frame. So first of all, we want to get input on every available update. So every time request animation frame does run this loop, even though we're not updating the screen necessarily, we are collecting user input because our game should be as responsive as possible. So even if I press before the actual redraw happens and the game logic runs, I want that to register so the user has the highest degree of control possible. So even before we check to see if 250 milliseconds has passed, we're collecting input from the keyboard. So that's important to keep note of. And then we're going to get down here and we're going to check to see if that 250 milliseconds has actually passed. So in order to do that, we get a timestamp. Every time request animation frame fires, it calls a function. So if I come down here, here's an example of where I call request animation frame perpetuate the loop. So I call request animation frame, and I tell it to execute the loop, the game.loop function, which is the function we're in, this function right here. And when it does that, it hands a timestamp, which is the number of milliseconds that has passed since the application started. I believe since the application started and not since request animation frame was called. So to match this, you can actually use window.performance.now to get the amount of milliseconds that has passed since the application starts. So this is really handy for keeping track of time and implementing fixed step game loops. So keep all that in mind: the accumulated time, the time stamp, and the time step. They are all very important. So first of all, how we actually test to see if that 250 milliseconds has passed, we see if the timestamp of our current game loop is greater than the accumulated time plus the time step. So basically that means if the amount of time that's accumulated is 1,000 milliseconds and we add our next time step interval to that, so we get 1,250, we see if the execution time of our game loop is, actually we should do greater than or equal to. That would make sense. So we check to see if our timestamp is greater than or equal to 1,250. And if it is, then we know that we need to execute another update to our game. You see if that affected this at all. It really shouldn't have, besides making it 1 millisecond more accurate. But that's how we ensure that the snake only moves at a set interval. And we can control the speed of that interval. And we do. We update it every time he hits an apple. And as you can see, every time I hit an apple, the snake starts to move a little bit faster. Maybe you can't see it, but it is happening. Can kind of gradually see him picking up speed there. Bam. All right. So once we know that the accumulated amount of time is, less than or equal to the current execution time of our game loop, we know that we can update. So what do? To make that functionality available for the next time we loop, we set the accumulated time equal to the current time of the game loop. And then we get into our logic. So first of all, if the snake is not moving, if we're in pause mode, if the snake is not moving, why would I want to update the screen? So here we just test to see if the snake's movement vector is anything but 0. If it's 0, then we're not moving and we don't need to update. So first of all, we have this if statement that says, hey, if the snake is moving, or if the snake is not moving, then we run all this game logic. Okay, I also have these comments in here to explain a little better if you guys want to go into the source code and just read the source code and look at it. I mean, choose whichever you want to do. Continue watching, go get the source code. I have the link in the description of the video. But I'm going to forge ahead here. So the next thing we do after we determine that the snake is moving is we test to see, what is this? I haven't looked at this code in a while. So we test to see if the snake's new head position is going to be equal to its old head position. And if it is, then we have to pause the game. Or basically we just stop the snake from moving. So if I'm moving up and I press down, the snake's head, when I move up, the tail is going to be moved to the next head position and it's going to become the new head. And each time that happens, the old tail is going to be moved up to the new head position. So when I track my head position and I'm moving up and I hit down, the next head position is going to be in the old head position. And if that's the case, I don't want to be able to move in that direction because you can't move. It's like if you were to move backwards into yourself, you just can't do it. A train cannot move backwards because there's a car right behind it. I mean, it can move backwards, but theoretically, if just the head were to move one space down the track, it can only move to where there's not another train car. It can't move to where there is currently a train car. So that's basically what's going on here. I'm just keeping track of the different train cars or the different segments of the snake. And if the previous space the head was in, being this space in this scenario, is where the new head is going to end up, I just stop the game. I set the movement vectors to 0. I request that the game loop start over again, and I exit the current game loop, preventing any of the further game logic from executing. So that's a really simple way of pausing the game. If I comment this code out, let's take a look and see what happens. I'm going to save that. I'm going to come over here, refresh the screen. And actually, nothing happens. I just am able to move backwards over myself. And I still have the functionality to kill myself whenever I hit a segment of myself. So if I have more than 2 tiles or 2 segments in my snake, I'm just going to die. But with only 2 segments, as you can see now, I can switch directions up and down, left and right, even though there are segments technically behind me. So now I'm going to comment that back in and move on to the next bit. Here is where we move the snake. So moving the snake is actually, it's really simple. All you got to do is take the tail of the snake and move it one step ahead of the head of the snake in the direction that it's moving. So for instance, if I'm going to move up, oh, what just happened there? Oh, I forgot to refresh. So I still have that broken functionality where I can't pause. So if I'm going to move to the left and pause my snake, what's going to happen here? If I try to move to the left one more space, the tail piece is going to be removed and it's going to be reset to the location of the head plus whichever movement vector that I currently have. So if my vector x was equal to -1, that tail object would be popped out of the segments array, deleted out of the map set to a 0, so we would have a gray tile here. It would be moved to the head position, and then it would have the vector of movement added to it in either of these 4 directions. So if I move one more space to the left, you can see that that tail was basically popped over from here and moves to here. If I want to move one space down, this tail is going to be popped from here and moved to here, and I'll show you that. That tail was popped from here and moved to here. So really simple, we're just taking the tail and moving it one step ahead of the head in the direction that we want to move. So really, really simple. So how we do that is with this code right here. Basically, we just pop that tail out. We set the tail index equal to a background tile in the map. And then we come and we set the old head index equal to the current snake.head index. That's just keeping track of that old head for that pause functionality. Then finally we come over here. Excuse me. We set the new snake head index because that's not really related to the segment array of the snake. It's just a placeholder for doing collision with the walls and the apple and the snake segments itself. So we take that new head index or that current head index and we add to it a complicated column and row type thing here. But basically what we're doing is we're just setting it equal to the index in the map where we would end up if we move this tail to the head position and added or to the head position and added our movement vectors. So say I want to move down again, this tail is going to end up right here, and this line basically does that repositioning. So to move down, that tail just pops out from here and moves here. So pretty simple. I'll show you the, well actually you can see the code for yourself right here, or you can go get it from the source. Just a really simple line right here. Next up, we got collision detection, and this covers a bunch of different scenarios. So first thing it does is it says if the head index of the snake in the map is equal to a snake segment, we hit a segment. So it's hard to say right now because it's hard to show you right now because I only have 3 segments, so you won't really get a good idea of what's actually happening. But if I collect a couple apples here, well, you couldn't really see it there, but basically the head index was equal to another segment of the snake. And when that happens, I'm just going to reset the game and exit the game loop. The other conditions that we have are basically testing against the wall or the different walls on the map. So if the head index is less than 0, and this is position 0, so anything above the top of the map, that's something we don't want, so we reset the game. If the head index is greater than the map length, that means it's going to be below the map. So if that's the case, we're going to reset the game. Actually, all these cases reset the game. The next 2 are a little more complicated, but they're basically the left and right sides respectively. So this would be the left side here, this code. So basically what you have to do to test for this is you have to first determine which way the snake is moving. So if the snake is moving to the left, that means its movement vector on the x-axis is going to be equal to -1. If it's moving to the right, it's going to be +1. So first we're going to check that left wall. So basically we just see, is the snake's head index greater than 0? And basically, if I don't include these 2 lines here, what you're going to see is something kind of interesting, and it's, well, I'll just show you. I'll just show you what it is here. I think this is the end here. So if I do this, hopefully I get some working code. No, I don't. Let's see here. Maybe commented out a parenthesis there that wasn't supposed to be commented out. See if I can get it right this time. All right, so what you're going to see now is actually pretty cool. When I exit off of one side of the screen, I'm going to come on, because basically what I have here is one big one-dimensional array of tiles. So this is position 19 up here. This is position 20. So when I move my snake's head to the next position to the right of 19, it's going to set me at 20. This is position 20, but the way I convert to a 2D map, I take position 20 and I set it over here. So what you're going to get if you don't include checks for the walls here like I did is you're going to get what you see on the screen, and that's the snake moving through the wall and either going 1 row down or 1 row up. So basically this just tests to see if that's happening, and if it is, I want to reset the game. So basically these are all the collision detection methods, and all of them result in resetting the game. Actually, there's one more collision detection method, but after we check to see if the snake is colliding with any of these things, if he's not, and this if statement is false and none of this code executes, we're going to set the current snake's head index, or the current head index of the snake, to a display segment to draw that head segment when it moves from the tail to the head. We're going to draw that to the map, and then we're going to unshift that head index back into the snake segment array so we can use it later on. Then we do our last bit of collision detection, which is testing to see if the head index of the snake is hitting an apple, or the apple. So since we're using indices in the map to keep track of everything, this is really simple. All I have to do is say, is the snake's head index on top of the apple? And if it is, actually, wait, come over here, test this out. If the head index hits the apple, I get a new segment, and my snake gets a little longer. So really simple check. When this happens, I increment the score up 1. As you see, I got 2 apples right here. Got 2 extra segments. Score is 2. Then what I do is I subtract 10 from the time step if it's greater than 100, because I don't want to go under 100 milliseconds between my frames of animation. And then I just add another segment to the tail. So I push the current tail and index into the snake's indexes or indices. Can never get that word in my head right. I always say indexes, but it's like deer and deers. You don't say deers, you say deer. You don't say geeses, you say geese. You don't say indexes, you say indices. But for some reason, I can never get that in my head, mostly because I'm typing the word and I'm never actually saying the word. So never really registers in my mind as something phonetic. So anyway, I set that tail index, that new index for the snake. I just push it to the tail. And then I come and I set the position in the map to a display segment or a snake segment, which is one of these yellow squares. This way I draw it because it's part of the map now. Then I go ahead and I try to get a random location for the apple within the bounds of my map. So there's 400 spaces, is a 20 by 20 map. 20 times 20 is 400. So I just get a random spot, a random index inside of those boundaries for my apple. But what happens if that random index lands right here and it's on my snake? I can't have it appear on my snake because that would be weird. That's not the kind of stuff you want to see in a polished game, not a polished snake game. So we have to come up with some conditions to test to see if the apple is on top of the snake. And if it is, we need to move it off the snake. So the first thing we do before we get to that is we test to see if the snake is actually 399 segments long. Because if the snake is 399 segments long, there's only one spot the apple can be, and we can't put it there. Actually, I guess this should technically be 400 spaces long, because that would mean the apple really has no place to go. But chances are it's never going to happen, so I guess I just went with 399. And if the snake is that long, you win the game. So I should put a condition in here that says congratulations, but I'm never going to be able to test that because I'm never going to be able to get 400 segments on the snake. That's just crazy. So basically, if it ever gets there, I have this condition in here. I reset the game and I break out of the game loop. And then we test to see if the apple lands on the snake with this while loop. So we just get that random index that we place the apple at, and we just say, while the apple's new index in the map is not equal to a background tile, so in the case that it's on top of the snake, we have to move that apple index. So say my apple index is randomly set right here on the snake. I'm going to enter the while loop. It's going to say this is a one tile or a segment tile, and it's going to move my apple index one space to the right. Boom. Then this loop is going to execute again, this while loop. It's going to move my apple one space to the right again. And then it's going to execute again and move it to the right one more time. And basically, it's just a way of moving the apple off the snake. And as I showed you before, if I'm over here on the corner, like if the snake is over here on the corner, if the apple spawns here and I move it one space to the right, it's actually going to pop out over here. So I don't really have to worry about the sides of the map. I do have to worry about the top and the bottom of the map. So since I'm moving to the right, I'm only ever going to have the chance of going off the map. So let's move the snake over here and show what a case like that might look like. So say my apple spawns here. It's going to execute this while loop a couple of times. It's going to move the apple, move the apple, move the apple. Then it's going to try to move the apple past the 400th space in the map array, which is not possible because I can never access it. It's not even defined in the array. So what I'm going to do is test for that. If the index is greater than the map's length, I'm going to set it back to 0. So if my apple is moved over here, it's actually going to be set back to 0, and that process will just continue. And since I do technically have one open space left for the apple, since I'm checking up here to see if the snake doesn't fill 399 spaces, it will eventually find that one open space. But chances are the snake's never going to get that long. You really don't need to check for that. So if all of that stuff happens and you find a free space for the apple, you finally set the apple's new index in the map. So the map has the apple in it, and when you render the map, you draw the apple. And finally, you call display.render. So actually, display.render is outside of everything else. Display.render is inside the bounds of this. If I come over here, well, display.render is inside the bounds of that if statement that was saying, you know, is the snake actually moving? So if I come up here and I just move my, I don't know what you call it, cursor, caret, one of those things. If I move it down, you can see that display.render is only called whenever the snake is actually moving, because we don't need to call it when the snake is not moving. And that's it. I think I explained everything to the fullest extent that I could here. Finally, in the game loop, we just request another loop to execute. The only thing left really is the initialization code, and all that does is it sets up the size of the buffer, which is where we draw everything to before it's scaled, because this is a scaling application like all the applications I make are. I have some code set up in the resize event handler to make the top and bottom text disappear. This way, if you want a more full screen experience, you can have it. Just extra stuff. I'm not really going to go into that. This draws, it loops over all those graphics objects that I was talking about earlier in the display, and it calls our draw functions to set up all the graphics. If I were to comment this line out and restart my application, everything would just be blank, simply because I don't have any graphics. If I was to come over here and say, well, actually, I'm not even going to test that, but basically this just draws the graphics. It calls the draw function in each one of my graphics. Finally, I come down here and I add event listeners for the keyboard, and in the case that the screen resizes, I reset the game to the default values and call resize on my display to set up the canvas so it fills the screen. And that, in 382 lines with lots of white space and code, is how to make a really, really simple snake game. I'm going to, excuse me, I'm going to put this code or a link to it on my GitHub in the description. I'm going to put a link to the working example in the description. Check it out on my website and check out the source code on my GitHub page. And check out this source code. Copy and paste it into your own application and fool around with it, because it's pretty cool. And that's it. I hope you guys learned something, and go ahead and make a cool snake game. If you did learn something and you liked the video and subscribe to the channel, because I'm going to have more stuff like this coming out soon. I think my next tutorial, I'm going to go over sloped tiles, and I got to say, I'm actually pretty excited about that. So stay tuned, and I'll see you guys next time.